morning, students. Yes, chapter 7, alternating current, RMS value. Yes, what is RMS value and why it is required? See here, AC voltage is given by V is equal to Vm sine omega t, or V is equal to Vm cos omega t. Similarly, AC current is given by I is equal to Im sine omega t, or V is equal to, I is equal to Im cos omega t. Means both voltage and current, they are function of sine or cos. They are function of sine or cos. Okay. So if we find value, if we want to measure value of voltage and current, that is value of V and I, with the help of simple voltmeter or ammeter. So this simple voltmeter and ammeter, they will measure instantaneous values. And as V is function of sine, so with respect to time its value is continuously changing. Yes or no? Yes. I is also function of sine or cos, so its value is also continuously changing. So yes, if you use simple voltmeter or ammeter, it will show instantaneous value. Means the device, the meter is continuously changing its value. It will continuously change its measurement. Okay. So yes, the device will measure instantaneous value, and yes, it is continuously changing. And as it is continuously changing, we have to find its average. Yes. V is equal to Vm sine omega t, put different values of t. V keeps changing, I keeps changing. Yes or no? So yes, that pointer on galvanometer, on voltmeter or ammeter, it continuously changes. So yes, we have to find its average. But average of AC voltage or AC current, as they are function of sine or cos, is C. Okay, it's average. That is average of V is average of Vm sine omega t. We have proved it is 0, or we can say average over a period. Okay, or I, it is also Im sine omega t, it is 0. That we have proved. Okay, because we know that, yes, we know that average of sine over a period is 0 and average of cos over a period is 0. So yes, AC voltage, AC current, we cannot measure with the help of simple voltmeter or ammeter. Okay, we cannot find its average because its average over a period is 0. So how to find AC voltage or AC current? Yes, some special device, one special device called AC voltmeter or AC ammeter are used. Okay, and they find and they measure RMS value. Now what do you mean by RMS value? RMS means root mean square. Value. Okay, now what is root means square value. How to find RMS value? How to find RMS value? See, we will see how to find RMS value with the help of one example. Okay, if you are given, okay, V is equal to Vm sine omega t, then find its RMS value. Find its RMS value. How to find? Yes, RMS, root of mean of square. So first step is square. You have to take square of this. Okay. So yes, it is V square is equal to, it is Vm square sine square omega t. Yes, you know this. Okay. First of all, you have to take square. Now we have to find mean. Means mean average over a period. So it is V square is equal to 1 upon, it is average of V square m sine square omega t is equal to, how to find its average over a period, that you know. Okay, it is 1 upon t integration 0 to t Vm square sine square omega t d. Yes or no? Yes, yes. So is equal to, it is V square m upon t. Okay, integration 0 to t. Integration 0 to t. Sine square omega t means 1 minus cos 2 omega t upon 2. Here it is dt. Okay, so yes, is equal to, it is V square m upon t common. V square t upon t common. In bracket here it is 0 to t 1 by 2 dt, then minus integration 0 to t cos 2 omega t dt. Sorry, 2 cos 2 omega 2 upon 2. Here it is dt. Yes or no? Yes, it is. So is equal to, it is V square m upon t 1 by 2 as it is. What is integration dt? It is t, and its limit is from 0 to t minus, it is 0. We have already proved. Okay, the average of sine or cos over a period is 0. So now if you put limit Vm square upon t 1 by 2, upper limit t minus lower limit 0. So yes, this 2 cut, this t cut, then it is Vm square by 2. Vm square by 2. Clear about this? So yes, here it is V square, its mean is equal to, it is Vm square. Now you have to take square root on both sides. So square root on both sides. So is equal to, it is under root Vm square by 2. Okay. So now how to read this? See, root mean square. Root mean square means it is called RMS value, and therefore Vrms is equal to Vm upon Vrms is equal to, it is Vm upon root 2. Clear about this? So yes, it is RMS value. See, it is maximum value, or we can say amplitude of voltage, and it is its RMS value. So it is relation between maximum value and RMS value. Similarly, if you are given V is equal to Vm cos omega t, you will get the same result. You will get the same result. Okay. If you are given current, then yes, for current you have to write equation like this. Okay, I RMS is equal to, it is Im upon. Similarly, I RMS is equal to, it is Im upon. So it is how to find RMS value. It is how to find RMS value. Clear about this? So yes, you have to remember this. Average of sine over a period is 0. Average of cos over a period is also 0. Clear about this? And if you remember one step directly, that average of sine square over a period is 1 by 2, then yes, you can write directly this step. Okay? So yes, it is all about introduction for this chapter. Okay, what is RMS value? Okay? Good morning, students. Chapter 7, AC currents. Yes, theory title is AC voltage applied to a resistor. AC voltage applied to a resistor. See, like this. It is resistor R, AC voltage is applied. Yes, AC voltage is applied like this. It is V. Okay. Yes, it is symbol of AC voltage. It is symbol of AC voltage. Okay, so yes, here resistor is connected between two ends of AC voltage. Resistor R is connected between AC voltage, and yes, we are assuming AC voltage means potential difference between two ends of AC this source is V, and that V is equal to, it is Vm sine omega t. Vm sine omega t. Okay, here one resistor is connected between AC voltage V is equal to Vm sine omega t, where what is Vm? Vm is called amplitude of AC voltage, or you can also say its maximum value. Its maximum value of AC voltage. What is omega? Omega is angular frequency. Omega is angular frequency. Okay, omega is angular frequency. So yes, here it is. What is Vm? What is angular frequency? That you have to remember. Okay, now yes, it is connected across. What you have to do? You have to obtain equation of current. You have to obtain equation of current. What is equation of current flowing from the circuit? What is equation of current flowing from the circuit? Okay, so yes, we have to apply Kirchhoff's rule. According to Kirchhoff's rule. According to Kirchhoff's rule. According to Kirchhoff's rule. Okay, what is Kirchhoff's rule? Kirchhoff's rule is sigma E is equal to, it is 0. Sigma E is equal to, it is 0. Okay, so yes, how to write this equation? You have to write this equation as V is equal to, it is IR. V is equal to, it is IR. Now what is value of V? That is potential difference between two ends of this AC source. V is equal to, it is Vm sine omega t. What is potential difference between two ends of resistor? If current flowing is R and current is I, resistance is R and current flowing is I, so it is I. Any doubt about this? Okay, so yes, now you have to make this I as subject, then I is equal to, it is Vm sine omega t upon R. Yes or no? So yes, I can write this equation as, I is equal to Im sine omega t, where Im is equal to, Vm upon R, where Im is equal to, it is Vm upon R. See, what is equation of V? V is equal to Vm sine omega t. What is equation of I? Im is equal to, I is equal to Im sine omega t. Yes or no? Yes, here it is. Yes, here it is. See, V is equal to Vm sine omega t. This omega t is called phase of AC voltage. Here, I is equal to Im sine omega t. This omega t is phase of AC current. So see, in this case, phase of AC voltage and phase of AC current, they are same. See, they both are function of sine omega t, sine omega t and sine omega t. They both are function of sine. It means what? See, if I draw graph, here it is. if I draw a graph like this, okay, then V is equal to Vm sine omega t. V is equal to Vm sine omega t. How to draw graph of sine? How to draw graph of sine? See, here it is. How to draw graph of sine, that we will see in that contact. Okay, how to draw graph of sine. See, here it is. If I have to draw graph of sine, it is angle theta. That angle 0. Here angle 90. Here angle, yes, it is 180. Here it is 270. And here it is 360. What is sine 0? 0. Sine 90, 1. Sine 180, 0. Sine 270, minus 1. And sine 360 is 0. So see, it is graph of sine. Any doubt? It is graph of sine. But what about graph of cos? What about graph of cos? See, here it is. What about graph of cos? It is theta. Okay, yes, it is of sine. Okay, now what about graph of cos? It is 0, 90, 180, 270. Here it is 360. What is cos 0? Cos 0, it is 1. Cos 90, 0. Cos 180, minus 1. Cos 270, 0. And cos 360 is again 1. So what is graph of cos? It is like this. See? So it is graph of sine and it is graph of cos. It is graph of cosine. So see, now here back to this theory. Okay, yes, it is theta is equal to omega t. This theta is equal to omega t. What is V? V is equal to Vm sine omega t. V is equal to Vm sine omega t means voltage is function of sine. Voltage is function of sine. So that it is voltage. It is function of sine. Clear about this? Okay? Yes. It is its maximum value, that is Vm. This side, here it is minus Vm. Any doubt? Okay. Now I is equal to Im sine omega t, or this equation, okay, I is equal to it is Vm upon R sine omega t. Vm upon R sine omega t. Yes, it is also function of sine. Current is also function of sine. Then how to draw its graph? Its graph is like this. Its graph is like this. Okay, when voltage is 0, current is also 0. When voltage is maximum, current is also maximum. When voltage is 0, current is 0. When voltage is minimum, current is also minimum. Yes or no? Yes, it is. So yes, as voltage changes, current also changes. Okay. Voltage 0, current 0. Voltage 0, current 0. Voltage maximum means positive, current positive. Voltage minimum, negative, potential. Current minimum. Clear about this? So yes, from equations and from graph, you can say, okay, here, voltage and current are in phase with each other. They have same phase. V and I have same phase. V and I have same phase. Means what is phase difference between V and I? Phase difference between V and I is 0. Phase difference between V and I is 0. You have to remember this statement. Clear about this? Okay. So again, we have AC voltage V is equal to Vm sine omega t. Apply Kirchhoff's rule. That is V is equal to IR. V is equal to Vm sine omega t. Make IR subject. Then I is equal to Vm upon R sine omega t. Vm upon R, I can write Im. So yes, this equation. From equations now you have to check. Okay, V is function of sine, cos is also current is also function of sine. So yes, that phase is also same. It is omega t. It is also omega t. Means their phase is same. Their phase is same. Their phase is same. Phase same. It means voltage 0, current 0. Voltage maximum, current maximum. Voltage 0, current 0. Voltage on negative side, current also on negative side. Means they are in same phase. So you have to draw figure like this. Now, there is one difference between voltage and current. It is maximum value of voltage. It is maximum value of current, that is Im. And here this value it is minus Im. Then why Im is less than Vm? Obviously, see, V is equal to Vm sine omega t, where I is equal to Vm upon R. Vm upon R sine omega t. Im is equal to Vm upon R. Vm upon R. That's why Im is less than Vm. Clear about this? So yes, you have to draw this graph. Then you have to write this statement. Now we know that here AC current that we have obtained, I is equal to Im sine omega t. AC current I is equal to, here it is Im sine omega t. It is function of sine. So average of AC current over a period is 0. Average of AC current over a period is 0. That is, average of I is equal to 0. But average of AC current is 0. Power dissipated is not 0. What is power dissipated? See here, instantaneous power dissipated. Instantaneous power dissipated in circuit. You know what is equation of power? Yes, what is equation of power? P is equal to, it is I square R. So I, yes, where is I? There it is Im sine omega t. So it is I square M sine square omega t. Here it is. Clear about this? It is instantaneous power, okay, at any instant, Now if I find average power, why to find average? Because this power is function of sine and value of sine continuously changes, so we have to find average. So average power P is equal to, it is average of I square M R sine square omega t. So we can write is equal to, it is I square M R constant, so it is average of sine square omega t. And what is average of sine square omega t? You know it is 1 by 2. So it is equal to, it is I square M R divided by 2. It is average power. Or we can also write this. We know one equation that we have proved. I RMS is equal to, it is Im upon root 2. Then I square RMS is equal to, it is I square M upon 2. So I can replace this I square M divided by 2 by I square RMS. So P is equal to, it is I square RMS into R. I square RMS into R. Clear about this? And this equation is similar to equation for DC circuit. For DC circuit means when battery is used, that is P is equal to I square R. That is P is equal to, it is I square R. Clear about this? So yes, it is one theory which is AC voltage applied to a resistor. Voltage V is equal to Vm sine omega t. Obtain equation of current. From equation of current and voltage, you have to draw this figure. From this figure, you have to write statement for phase reference. Then, yes, average current is 0. Then what about power? Yes, instantaneous power, and it is average power. And average power is equal to this. Average power is equal to this. Clear about this? So yes, it is whole theory when your title is AC voltage applied to a resistor. Clear about this? Yes, for today, this is it.